Mr. Miller, let's do this thing. You got your coffee? Yeah, I got my coffee. You got your calculator? Check. All right. It is December 11th. Let's rock and roll. Let's see what we got here. We're going to try to do as many as we can. All right. Okay, so what do we got here? Multiply. All right, so these are, I got to find the area, right? These are the dimensions of a rectangle, and I got to find the area. So eventually you're going to get the 4. Well, if I think about it like this, I can draw it if I'd prefer. You don't have to do that. Okay. So now I got 4 and 4a times 5a is 20a squared. All right. Feeling settling in. All right, so there's the 20a squared. Here's the minus 31, the 12. All right. Number 2, factoring. Oh, I see a leading coefficient of 2. So I know what I do when I factor. I am doing fancy rectangle math. Cool. All right, my 2x squared, you're going there. My 6 is there. Beautiful. I need two numbers that add to 7, but when they multiply 2. Don't you say 6, it's 12. It's that number times that number there, all right? Okay, so that's going to be 4 and 3. So I'm going to put the 4x here and the 3x there. So now this is 2 times 1, so I got to put the 2 here because 2 doesn't go into 3, so that allows that to be plus 2. And I'm going to put x there, which is plus 3. So we are 2x plus 3, x plus 2. 2x plus 3, x plus 2. Okay. Order doesn't matter, right? 2 times 4 is 4 times 2. All right, another multiplying question. So I know when I multiply these two are going to get multiplied together, so that's definitely going to give me 15k squared. Oh, that didn't help. The 4 times 8 is going to happen. That's going to give me positive 32, so that one's out. So now I just got to figure out that middle term. So this 5k dimension is going to multiply by 8, and that's going to give me 40k. 4 times 3 is going to give me 12k. So I'm going to have 52k area in my rectangle. So we are at D. Okay, 4. So we are factoring, leading coefficient of 1. So this one factors x plus 9. By that I mean 6. X plus 3. And this one, it's an interesting one because of that plus 1. I know a lot of times students trips them out for whatever reason. So we're here. We need two numbers that add to 1 but multiply to negative 30. And I always tell students this is actually a really good clue that the two numbers have to be consecutive. It's going to have to be like 7 and 8, 9 and 10, 11 and 12. Like that's the only way you're going to add to positive 1. And one of them has to be negative. That's how you multiply to a negative. So this has to be 6 times 5. And if we're adding to a positive, then the bigger one's got to be positive. So we're 6, negative 5. So we're going to be x plus 6, x minus 5. And so x plus 6 is the common factor because it's both here and here. All right. Well, hopefully you look at this and you say, oh, hell no, there's no middle term. Okay, and it's not that one either, no middle term. It's got to be one of these two. So if we got 3x squared, so 3x minus 7 and 3x minus 7. Of course, we have the 9x squared and the positive 49. But we also have the minus 21x, and there's two rectangles like that. And so they are going to add to 42, and we're there. All right, 6. All right, we got x minus, we got to get to 24 and we got to add to 11, so it's probably what, 8 and 3 where they're both negative. Yeah, all right, 8 and 3 where they're both negative. All right, we're doing good. Oh my gosh, 2. I think that's actually the third multiplied by a binomial. Mr. Miller, is that going to be on the test? Well, it's on the practice final 3 times. What do you think? Well, it sure ain't those. Not going to have only the 2 terms. All right. So, and now here, you're going to get negative 4 times negative 4. So it's going to give you positive 16. So it has to be that one. here, these are both positive, but this value here doubles, right? Because it's going to be in two places, so they're going to be A. Okay, so perfect square trinomial means I can draw it as a square. I can represent this as a fancy square, and you ain't gonna, that's not that one. That 21's not a square number. This one's cool, right? Because it's x plus 11 squared. This one's not cool because that has to be positive if it's a square. It can't be negative 16. So now we're here, and this feels like it's going to work because that would be 3x minus 7 squared, right? Because minus 7 times minus 7 is here. In fact, didn't we just multiply this one? Isn't that one like over here? Oh, yeah, we just literally multiplied that one to get to this answer. So this one's also a perfect square. You can draw that as a square. I actually might just draw it as a square because, so if it's a square, you better be able to do this. Cut that middle term in half. That value should fit right there, and that should just work. 3x times 3x minus 7, and it does. All right, 2 and 3. This needs to be plus 25 if this is going to be a square, so n has to be 25, and then it would be plus. All right, moving on. We're making these videos. It's always like, how much should I explain? It was 60 problems. If I talk too long on each problem, you're looking at quite a long video. So, all right. So one of these is a factor. All right. Well, if I'm going to factor it, I'm going to add to 60. Well, I multiply to 63. I feel like that's probably going to be 9 times 7 because those add to 16. And if they're both negative, we'll add to a negative. So it's going to be x minus 9, x minus 7, or d, I suppose. So d minus 7. All right, what factor do they have in common? Well, the easier one to factor is over here, right? So you got x plus 6, x plus 5. So we're not that one and not that one. And of the rest of them, 6 isn't going to go into 35. So that means it has to be x plus 5 at this point. If we want to try to, well, I'm just going to move on. That's what it has to be, that one. All right. So let's keep going. Long video here. Okay, so 13, finding the vertex. Finding the vertex when it's in vertex form has got to flow like water down a stream, right? It's got to flow like syrup on pancakes. All right, -9. This -4 is just distracting us. It doesn't do anything to the vertex, so we're -9 too. -9 makes the square go poof. And when this square goes poof, y is equal to 2. All right, so vertex. I'm going to find the vertex by converting to vertex form. So let's convert to vertex form. All right, so I'm going to make a square. It's going to be x and x. I'm cutting that in half. So I got x plus 1, x plus 1, and 1. So I'm going to add 49 to both sides. So I'm going to get y plus 49 is equal to x squared plus 2x plus 1. So y plus 49 is x plus 1 squared. So y is x plus 1 squared minus 49. So we're at -1, -49. 16, we got to find the vertex, and we have, it looks like some intercept form. All right. Well, how you find the vertex is let's find the intercepts and split the middle. So 4, 0, and 12, 0. So that's a step of 8, which means if you add 4, you got to be in the center. Now let's put 4 into this equation. So y is going to be, put 8 into this equation for x. So 8 minus 4 is 4. 8 minus 12 is -4, which is -16. So 8, -16. All right, keep it going. So vertex. Vertex is at -7, +3. That's for sure. And all of these say that, so that's not helpful. Well, it's a maximum, so let's get rid of these minimums. And the value is the y function. So the value is 7. The maximum, the value is 3, and that occurs at -7. So the maximum value is 3. Vertex. Okay, I think I even got room to do this. I know I'm going to make this, should be x plus 5 squared. That's going to be 25. So I got to get all the way down to 11. So I got a minus 36. And so it's B. Another way of thinking about that is just make your square. So you got x squared, 5x, and 5x. 25. And so you'd have to add 36 here. And then eventually you'd have to subtract 36 as the last step. Hey, there we go. We're rolling. Feeling good. I know I have some of these where there's no right answer. I kind of made a mistake. This is I printed an earlier version, so we may run into some mistakes here. We'll see. Okay, so it's a vertex and has an odd middle number. So nothing we can do. We're dealing with decimals. The answer is a decimal. That's just what it is. Okay. When that leading coefficient's 1 and you got an odd number, you're dealing with the decimal. So it just simply isn't going to be A or C. So let's see. I don't know what it is. I know I can figure it out by making a square. I know that. So I'm just dealing with decimals. So I just have the 2.5 and 2.5, which is 6.25 when you multiply those together. All right, so I need -3 to be 6.25. So I need to add 9.25. So it's already this one because it doesn't have anything to do with the number 12.25. But let's just finish it out. So it'll be a little bit more helpful, but you could just end the problem at this point. All right, so there you go. It's going to be x plus 2.5 squared, and now you minus the 9.25 because we want to solve for y. And we're beautiful! And we're taking a sip of coffee. How we doing out there? We good? Hopefully. All right, so we've got a center and a maximum. So we know that A's got to be negative. Not that one. And it's not that one. Those are going to have minimum values. This is giving us intercepts, not a vertex. This actually has intercepts at 7 and -12. But that would be more like 7, 0, -12, 0. So it's not that one. So it has to be this one, and it just does have the right vertex, 7 and -12. So it's got to be that one. All right. Converting forms, aren't you beautiful? All right. Well, we've got these here yet again. We're multiplying x minus 2 times x minus 2. Converting to standard form always means multiply. Standard form doesn't have any special parentheses to highlight critical characteristics. So I just multiply that whole thing out, and I end up with y is equal to x squared minus 4x plus 4. But we still have that plus 5, right? That's still there. If we think about that and that, those are the same, or those are equivalent. So at the end, I do have to add 5, so I'm going to go plus 9 is the answer here. And we've got 1. Which of the following intercept form is equivalent? So this is a factoring problem, right? That's how we go standard to intercept form. So we're multiplying to -15, but we add to 5. We add to 2, which is definitely going to be 5 and 3. So we're adding to a positive, so let's make the bigger number positive, and let's roll with that, and that's C. All right, 23. Are you still with me? You good? All right, standard form to vertex form. That's cool. We already did that when we were looking for the vertex. So let's just go ahead and do that. I already know I'm going to cut that in half. It's going to be 5. This isn't going to be 10, right? I'm going to have to cut that term in half. So we got these two possibilities. So that's probably the answer, because this number here shouldn't be the same as the y-intercept. But let's just go ahead and figure it out no matter what. So I know I'm doing the minus 5x, x squared. There we go. So there's the x minus 5. That was the first thing I kind of already knew. Now I've got to add 13, and that's going to ultimately be my minus 13, because I'm going to have to subtract it as my last step, right? Okay, cool. So you minus 13, and you get A. 4. I know this is going to trip some of you out because you don't like this no constant at the end. So feel free to write plus 0. Okay, vertex form. Well, we know it's going to be x plus 4, so you might as well just circle the answer and go on to the next problem if you'd like. I mean, it's got to be that one, you know. And you can do the math, but, you know, you're going to have this square, and the square is going to have a 16 area, and you're going to have to add 16 to both sides. And then ultimately minus the 16 over here. All right, let's keep going. We're trying to make a video. We got, what, 16 minutes in? All right, we good. We good. We'll pick up speed here, maybe. Well, until we get to the solving. All right, I like this one because here we go. This is, we factored a ton. We multiplied a little. So I think this one's probably more difficult for a lot of my students this year than factoring, actually. So let's just do it. I mean, it's not difficult. You just have to remember what to do. Is standard form is always multiplying. So let's multiply these out. You're going to have this x times x action, which is shown there. You're going to do x times negative 9, which is that area there. You're going to do negative 3 times x, which is this area. And you're going to do negative 3 times negative 9, which is that area. You add all these up, and these are going to be minus 12, and that's 27, so you're at C. Next one. Okay, so we are converting to intercept form. All right, well, I know it's not A or C. Oh, look at these two C's. That's weird. Should note that error still exists. Okay. Because these are going to be positive 6 when they multiply out. So it's got to be one of these two. This is one's going to add to minus 5, so it's going to be D. So let's just go with D. All right, you can factor it if you'd like. Okay, which of the following is equivalent? All right, so we have a tough problem because we're looking at all three forms. So I have standard form, I have vertex form. So first thing to do is just multiply this thing out and just see, is it one of these two standard form? And it isn't, because these multiply to positive 32, and that's positive 12, and that's negative 32. So it shouldn't be any of these, and in fact, if we do multiply it out, we're going to get x squared minus 12x plus 32. So now we can just put this into vertex form if we want, or we can find the vertex using intercepts, which I would actually prefer to do here. So that's what I'm going to do. So 4 is 0, 8 is 0, which means 6 is the location of the vertex, which means it has to be C, because that one has a vertex at 6, where this one has a vertex at 4. And if you plug in 6 for x, you would get 6 minus 4 is 2, 6 minus 8 is negative 2, 2 times negative 2 is the minus 4 for the vertex there. All right. 27, which of the following quadratic functions, let me just quick battery check here. Oh, we're doing good. All right, never mind, we're doing fine. All right, is equivalent. All right, so equivalency, I have a bunch of vertex form and I have an intercept form. So what I got to do is find the vertex here, and only one of these is going to have the correct vertex. So let's do that. Let's get that part done. So let's see, I got x and y, so at negative 2 and 10, we'll have our intercepts. So that's 12 steps, so if you move 6 steps, you'll be in the middle, which is 4. If I plug in 4 here, I get 4 plus 2 is 6. 4 minus 10 is negative 6. You always get this nice plus and minus off the same number. We get negative 36. So that's the vertex. So the D is the only one who has a vertex at positive 4 and negative 36. It's got to be D. Okay, x and y intercepts. Okay, we're doing good in the room today. Yeah. Hey, salute. Was it Chintari? I learned a cheers in Italy. I thought it was Centauri. Maybe not. I can't remember. Been a while. It means to 100 years. All right, y-intercept, that's cash money. That's the only thing you get from standard form, so beautiful. Just make sure you know it's x equals 0. Y-intercepts have y values. X is always 0. X-intercepts have x values. Y's are always 0. So I'm going to make... Oh, this is the one that... So my printed version doesn't have an answer here. I turned C, so if you looked at the online version, I turned C into the right answer, which is 5, 0, and 12, 0. Okay, so my bad there. Remember when x is 5, y is forced to 0. And when x is 12, y is going to be 0. So therefore, those are the two values that you input into the function that force the function to go to 0. Okay, 30, x-intercepts. Well, you know, this is one where we have the two ways of doing it. You can factor or solve. So we've got options here. You've got this even middle number. So it's kind of up to us, whatever we want to do. If we want to factor it, we can just factor it. It'd be the fastest way to do it. X plus 7, x plus 3. This is another one that has no answer on this printed one. I'm sure I've updated it now, but at the time of printing, that was an error. So they're both negative, because if you're going to add 7, then being at -7 is when 0 is going to occur. And this dimension is always like 3 more than x, so when x is -3, the dimension is 0. Okay, we're rolling. Again, you can also set it equal to 0 and solve the equation, but we're going to have solving equations later, so I'm not going to do that here. All right, the graph of which of the following functions has x-intercepts at -4 and 5? Well, I really hope it's A or B, because it's a question about x-intercepts. And let's zoom in a little bit, actually. Whoa, maybe not that much, but just a little bit more. Yeah, I can move this thing around so you can see slightly better. All right. Well, and it looks like it's right there at the top. All right, perfect. I'm not going to look at any of the other ones. That's got intercepts in the right spot. Done. Okay, 32. Oh, good. Oh, these are my favorite. Correct graph. Well, this thing is pointing up, so it's not that one. Those two would be pointing down. Only one of these is going to have a vertex in the right spot, and that would be B. No, by B I mean A. Because B has the vertex at -4, so 4, -4, it has it down here, where this is 4, +4. And just notice that A value of 2, over 1, up, 2, over 1, up. 8. Okay. Brain freeze. Number 33, okay, this thing is pointing down, so sorry, A and B, you're out. All right, only one of these is going to have the right x-intercept, so we are at +4. So that would be this one. This one has a x-intercept at -4, so we are at D. Still going here. Okay, 34. Which function matches the graph? Oh boy. Well, hey, I know it ain't those two. Good job, Miller. It's got to be one of these, and you know they have the same A value, so it's got to be about the intercepts, and B is at +3 and +5, so not there. This would be -3 and -5. All right, which function matches the graph? Oh, come on. How are you going to give me all... You're going to give me all standard form, huh, Mr. Miller? That's what you're going to do to me? All right. Well, these intercepts are at... This y-intercept is at -1, but the y-intercept is up here at +1. So you're done. It's got to be one of these two. If I start to make the square, I can kind of maybe fold this paper back a little bit here. All right. If I start to square from, say, this one here, oh, move it up, move it up, move it up. Okay, maybe I zoomed in too far. Yeah, maybe it was just right initially. I start going like this, right? And I split the 2x, and x squared, so I get x plus 2 times x plus 2. So I'm going to be at x plus 2 squared. which is going to be at -2, which is where this is. So this one is going to give me x minus 2 squared, which would be have a 0 at +2. So it's going to be that one, because ultimately it's going to be x plus 2 squared minus 3. If you convert this to vertex form, and this vertex is at -2, -3, which is right there. All right, we're doing good. We're at another problem 36, perfect square problem here. Okay, well, which ones do I get to just ditch because of the a value? That's my favorite way to start. Boom, boom. Okay, we're at negative x-intercept, so we should see some plus signs because that means negatives will create zeros. And we are at D, -7 and -3 create or force y to be 0. So if you think about it as a function machine, if you input -7, the output will be 0. All right, 37, correct the equation for the graph. All right, well, hey, these are all +0 because this thing is not shifted up at all. All right. Oh, this is an a value thing. Oh, cool. Over 1, up 1, over 1, up 3, over 1, up 5. That is a = 1. I know that pattern. I've heard that song, Mr. Miller. Oh my God. I'm about ready to do 5 problems really, really quickly. All right. This function has 1 x-intercept. I should literally say only 1. I mean, it has 2, but I'm going to go false. That's what I meant when I had that problem. I mean it to be false. The online version, I'm going to fix that to be only. Make a little note for myself. Okay, 5, 0 is an x-intercept. That's over there. True. X = 1 is the line of symmetry. So line of symmetry is the straight line that cuts the parabola in half, and it's also the x value of the vertex. So if we go here, we go over 1 and up 3, so the vertex is at 1, 3. So x = 1 is the axis of symmetry. So true. Has a minimum value. False, it has a maximum value. It's at top of the mountain. And the vertex, that's true. All right, so if you're going to multiply this by -2, it's going to flip and point downward. And it's going to change faster. You're making the a value like a larger value with respect to 0. Like if it was 2, it's now going to be 4. -4, but either way, it's going to be narrower because it's going to go down faster than it would if you just multiplied by, say, -1. I don't know if that made any sense, but it's narrower because you're multiplying by a number bigger than 1. How about that? All right, so this one's less than 1, so you're actually going to take that a value, and the a value is going to get closer to 0, right? This a value is going to get closer to 0. And it's going to stay positive because it's a positive number. So this one's just going to still point upwards, but it's going to be much wider. So it's not going to be narrower. And it's still pointing up. All right. Cool. Hey, that's not bad. Initially, I didn't think I was going to finish. I think, man, maybe I will. All right. So the minimum value always occurs at the vertex, right? So there's this point when that square goes poof, and that's the smallest it will ever be. Because this square up here, this thing that I'm highlighting, this square can never be negative. When someone calls you a square, they should be saying you are eternally positive. On your worst day, you're neutral. So that's going to happen when x is exactly 2, because this is a square whose dimensions are 2 less than the x value. So once the x value is at +2, it's a 0 by 0 square. So x = 2 causes the minimum value, which is 4. So x = 2. All right, 46. Okay, so this is kind of fun. So we have a vertex at -2, 1. So I'm going to start by just writing an equation that at least has the vertex in the right spot. Now I look down, and it is now, at least I'm only halfway. It's got to be one of those two, and I could just guess if this problem is one that I'm not sure how to do. I can at least guess here. How you do the problem is you look at that other point and you plug in those values of x and y. and that will leave only one a value that is possible. So I plugged in the -4 for x, the +1 for y. So 1 is equal to a. This is going to be -2, so that's 4. +1 to both sides, divide by 4. So a is a half, right? So it's got to be b. All right. Part 7, graphing. Oh my gosh. I'm going to do those last because even as I write them, I say they're not on the final. So I'm going to do those ones last just to try to make the video a little shorter. Not a lot shorter, just a little shorter. All right, here we go. We rolling here. So these are ones that this will take me a long time if I solve each problem, you know, like both ways that we can do it. So I'm going to kind of mix and match. So this time I'm going to try to factor it. So I'm going to set it equal to 0. This is a -1 here, right? So I got to multiply to 56 and add to -1. 56 is 7 times 8, so I know that's going to work. So we're going to go n minus 8, n plus 7. And if these two values multiply together and equal 0, then all I got to do is figure out, like, what makes this 0. Because that's the only way to have an area 0 is if one of the dimensions is 0. So in this case, it's n equals 8, so that's going to be one answer. And in this case, it's n equals -7. So there we go. Done. 52. You know, I see this even middle number. I might think that, maybe I'll draw some squares here. Maybe I'll just draw some squares. Why not? 4r, 4r, 16, x squared. All right, so I need this to be a 16, so I got to add 36 to both sides. So that's going to give me x plus 4 squared is equal to 36. Right? All right. Square root both sides, which gets rid of the square. That means if the square's area is 36, then the side length is either 6 or -6. And now if I minus 4, -4, 2, and 10, -10. All right, 3. So this is one of the ones where like in this version, none of these answers are going to be what we're going to get because we haven't learned to simplify radicals yet. And these are simplified radical problems. So I'm going to do the answer and leave it as an unsimplified radical because this is January 11th. And we have a final next week where we don't have to simplify radicals. So let's do it. All right, so, well, first thing is I got to have all these x's on the same side. I don't really care that it equals -5. I'm just going to leave the -5 over there. All right, so I can't have this as an odd number, so I'm going to multiply by 3. You're going to get 9x, well, this should be squared. 9x squared plus 30x is equal to -15. Now, I could actually work this problem now because I can make a square, because if I cut that in half, I'm at 15, and 3 is going to go into 15, and then I will get one of those answers. So why don't I just do that now? I mean, what a lot of students do is you could multiply by 4. That always works. And if you multiply by 4, well, let me think about it for a second. But right now I'm just going to do this problem. So, and then I will actually get one of those answers. So we got 9x squared. You get 15x and 15x. So this is 3x and 3x. See, this is why I didn't multiply by 4, because I knew I would be able to do this. I would be able to get 3 into 15. All right, let's get this. Make sure I'm still on the screen here. Okay, so I got to add 25 to both sides, all right, because I currently have a 0 over here. I don't have any values over here, so I'm going to add 25. I'm going to get 9x squared plus 30x plus 25 is equal to 10. So 3x plus 5 squared is equal to 10. So 3x plus 5 is equal to plus or minus the square root of 10. So now I have to minus 5 and divide by 2. So if I minus 5 and divide by 2. By 2, I mean 3. Divide by 3. Okay, so it is actually A. And I felt like when I had done it with a student before, this is going to be off memory, but I believe there was negative 10 plus or minus the square root of 40 over 6, right? Because the step that, and that's what you would get if you use the quadratic formula too, or if you multiply this by 4, you'll get to that. And then from here to here, which we don't have to do on this test, you have to simplify that radical. So it'd be plus or minus 2 root 2 over 6. And you got these 3 even numbers, and you can divide them all by 2. And you get, oh, sorry, it's not root 2, it's 10. Yeah, but either way, just kind of showing you that that's, so if you got this answer, bravo. On our test, I'll leave it. Well, I'll resolve that on the test. Maybe I'll put both answers on the test. Okay, but that's how you solve a level 6 problem. All right, 54, another solving. I see all these radical answers, so gonna have to do the Quadras method. No way around it. No way around it. All right, at least these numbers are kind of small. So I moved the x first, so I subtracted x from both sides, and x minus x is 0. I'm multiplying everything by 4. It's not factorable because 3 has to be 3 times 1, so I'm not going to be able to add to 1. But that's okay, I'm fine. All right, make my squares. Actually, let's think about it. I'm good. It's fine. I'm not in a hurry. All right, minus 1, minus 1, 1. Okay, I need this to be a 1, not a minus 12, so it's plus 13. Get 4x squared minus 4x plus 1 is 13. 2x minus 1 squared is 13. 2x minus 1 is plus or minus the square root of 13. Well, 2 of these are root 11, so those are gone. And I need to add 1 and then divide by 2. So when I add 1, I'm going to have that plus 1 at the front, plus or minus divided by 2. So there we are. D. Almost there. Almost there. All right. Solve. Don't mind if I do. All right, so I see all these integer answers, so I know I'm going to be able to factor this, and it might be something that we just try anyway. So I'm going to subtract 5, make this equal to 0. 5 minus 5, 8 minus 5. This factors to x plus 3, x plus 1. And if I factored an equal to 0, I am cash money. Nice quick problem there. If you treat it as a level 4 and you just draw your squares, you'll get that answer too. Don't worry. It ain't even that much slower. All right, here we go. One solution. Okay, well, let's see. So I have x squared minus 7x. I'm going to bring the 12 over, so I'm going to actually just plus 12. Go plus 12 is equal to 0. And I do that because I can kind of see that it's factorable. It's going to be x minus 4, x minus 3. So x is equal to 4 and 3. So 3 is one of the answers. And if you're going to roll this as a quadras problem, it doesn't matter. You can do it. It's cool. It's fine. It's fine. Just do it. Just do it. You're going to do 4x squared. You're going to get your negative 14x and negative 14x and 2x and 2x and minus 7. This is going to be 49. You're going to have to add 49 to both sides. And you can finish it. You know where you're going. You're getting 4 and 3 if you do it right. All right. Here we go. Well, let's keep going. All right. X squared plus 6x plus 5 is equal to 21. All right. I don't know. I'm just drawing some squares now. I like the even numbers. I do. I kind of enjoy it. I'm going to add 4 to both sides. So I'm going to get x plus 3 squared is 25. So x plus 3 is 5 and negative 5. So I have to minus 3. Okay, we rocking and rolling now. We rocking and rolling now. Oh my gosh, I'm going to have time to even go back and graph those things. All right. Oh, we got an odd middle number, and we got a bunch of radical answers. So we are going to factor this thing. Yeah, that's what we're going to do. All right. So let's do it. All right. So I'm sorry. We're not going to factor. It's not going to factor. We're going to make squares. Getting tired. Getting tired. No worries, no worries. We all right. We all right. Okay. We all right. All right, so we got there. I need 9, so I got a plus 32 just to get to 0. So I got a plus 41. So it's not going to be any of these square root of 23s. All right, so 2x plus 3 is equal to 41. So I'm going to have to minus 3 at some point. So I'm going to divide by 2. This is my last step. So finish the problem, but you should get that one because of this. This is going to be a divide by 2. All right, how many solutions does it have? No problem. It has 1, which is negative 5. This one has no solutions, okay, because x squared can't be negative 20. You can't have a negative square. All right, well, that's the whole final. Let's just go back and do these last 4. Why not? Out of just kind of completeness, I suppose. I'm just going to find the vertex. That's how we're going to roll here. So we're going to have x plus 1 squared, and that's going to give me a 1. So if I got to get to a 3, I'm going to have to add 2. And you can do that conversion however you want. So you're going to go back 1, up 2, go over 1, up 1, over 1, up 3, over 1, up 5, and make it happen. Over here. All right, so this is going to be, again, I'm going to just convert it to vertex form. So it's going to be x minus 2 squared. That's what I'm going to get when I here. That's going to give me a 4. If I got to get down to negative 1, I'm to minus 5. Again, you know, we don't always do it like that. You can, if you want to draw the square, you could draw the square. But I can see the battery on my laptop is almost out. So I'm going to really zoom these last few. Oh, hell yes. Pardon my language. It's vertex form. So 3, negative 8. Perfect. Oh my gosh. Thank you so much. All right. The A value is 2. So over 1, up 2. Over 1, up 6. Over 8. Right. You double the pattern. So instead of, but it's over 1. Sometimes I even have to. Over 1, up 1, 3, 5, 7. So it's 2, 6, 10. Yeah, it's not 8. Felt wrong when I said it. Okay, so over 1, up 6, and there we are. Okay. So yeah, you know, there's no reason to be in a hurry, I guess, that I'm in kind of now. But my battery is dying, so that's why I'm in such a hurry. Okay, so 1, 3. So let's graph those. That means the vertex is going to be at 2. So if I plug in 2, 2 minus 1 is 1. 2 minus 3 is negative 1. But all that's like also multiplied by this negative 1, right? So this value here is like that value there. So negative 1 times negative 1 is positive 1. So we're going to go up there, and we're going to point down. So over 1, down 1, over 1, down 3, over 1, down 5. All right. That's the practice final. If you're watching this video, I admire your tenacity, and I'm rooting for you. All right? Stay hip and be kind to each other. Bye-bye.